In this video, we're going to continue doing more two-sample t-tests, but in this case, we're actually going to use the data that is actually given to us. So here we have a chart showing the data between the weights of two competing vacuum cleaners. With an alpha of 5%, is there enough evidence to claim that both machines are the same? Assume a normal distribution. Okay, well, what is there to do here? Well, what we could do is we could put these into a list and figure out the average and standard deviation. But what's kind of nice about this is that the calculator will do all the work if we put this into list 1 and list 2 of your calculator. So we're going to hit the stat button, and then we're going to hit the enter button. And this is where you enter the stats on the Texas Instruments calculator. So I don't want to go any further until I get down what it was saying about the hypothesis test, though, because it says, is there enough evidence to claim that both machines are the same? That is definitely a not equal to problem. Now, what do I want to use? Let's use X and Y for brand X and brand Y. And therefore, our null hypothesis is going to be that they are not statistically different enough. Okay? Step 2, since we are assuming a normal distribution, we don't have any worries. Though the sample sizes are definitely under the n of x and the n of y, they're both definitely under 30. So we don't need to worry about that. So now we get to step 3, 4, and 5 after we type the data into the calculator. Now make sure that when you type your data into the calculator, if you click the stat button and you click the enter button, make sure your list 1 and list 2 are there and that they have data all cleared out. Now, as a reminder, if you have data in your calculator, like me having these 3 data points, you can go to the very top where it says L1 and it's highlighted, and you can hit clear and then you can hit enter, and that will clear out your data for you. So what I'm going to do is pause the video and type in all of this data by just clicking the number and hitting enter. And I'd like you to do the same until list 1 is filled with brand X and list 2 is filled with brand Y values. Okay, so now that we have both lists, so brand X in list 1 and brand Y in list 2, then we click on the stat button and we move over to the tests, and we're going to go to two-sample t-test. But in this case, we're going to move over to the input and select data. Because we've entered the data into list 1 and list 2 respectively, and we want the frequency of the frequency of the numbers in both of those lists to count for 1, since we're not doubling or tripling these values. And in terms of the mu1, we have chosen that mu1 is not equal to mu2. We're not choosing to pool the data, and we're going to choose draw. So we hit the enter button, and we see a beautiful two-tailed test starting to get rendered here on the screen. And we're going to write down our t-value and our p-value, and then the picture, and then do some short analysis to figure out what we should do with our null hypothesis. So let's start off with writing down the t-value, which in this case is negative 1.2919. And the p-value, which is 2.2441. Okay, so we have a two-tailed test. And we have two shaded zones here and here, because it's two-tail. And we're going to plant our flag here at negative 1.2919. So what this is saying is that our group was only different by negative 1 standard deviation below the norm, which isn't that far out of normal range, okay? And also, the percentage chance of landing in either space was 24.4%. That p-value does not feel rare. The p-value, which is at 24.41%, versus our alpha, which was at 5%, 24% is greater than 5%, we're definitely not rejecting here. So in our conclusion, we write down our inequality. Since P is greater than alpha. We do not have sufficient evidence to reject the null hypothesis. All right, so do not reject the null hypothesis, which means that there's no clear winner brand-wise for the weights of a vacuum cleaner. Looks like they're statistically the same, and it was kind of nice that we were told in the problem that we had normal distribution. And the reason why I was kind of very kind of quizzical about that, because if you actually do look at the data, especially brand X, that 20, it really feels like an outlier. But we assumed a normal distribution, so there's no reason to do an outlier check. Now in problem 5, I will actually do, I actually will give you the skills on how we could do an outlier check here if you needed to, even though it did say assume a normal distribution right here in the problem. So let's just go to step 0 and step 1, and we are going to make sure that we hit stat and we hit enter, because we're going to need to enter this data as well. So the number of grams of carbohydrates contained in 1 ounce servings of randomly selected chocolate and non-chocolate candy is listed. Is there sufficient evidence to conclude that the chocolate candies have significantly less carbs than the non-chocolate candies? Assume your normal distribution of 10%. Alright, so I'm going to pause the video and type in the data so we have it for the rest of the problem. Okay, so I now have everything loaded into my calculator. So what I'm going to do is check out step 1, which is my null hypothesis. My null hypothesis is that the first group, which I'm going to call chocolate, is going to have the same amount of carbohydrates as the non-chocolate. So this is going to be mu2. You can use different subscripts here, whatever is going to make it easy for you. But in this case, what we have is we want to see chocolate versus non-chocolate here. Okay, so if the chocolate is 1 and the non-chocolate is 2, what I'm going to do is I'm going to see, like, okay, what are the chances that the chocolate is less than the non-chocolate? Okay, so in step 2 we have N1 plus N2. It's less than 30, and since it said that there was no need for us to check for an outlier, we don't need to, because we can assume a normal distribution. But in case you do want to check for an outlier, what you need, now that you have your stuff in your list 1, we can go stat and we can go right and we can click enter and choose the one variable statistics. And what's great about the one variable statistics is that if you use that, you can either check list 1 or list 2, and it will let you scroll down to get your Q1 and Q3. The Q1 and the Q3 are necessary because the Q1 and the Q3 let you get your IQR, and the outlier check is when you go the Q3 plus the IQR times 1.5 and the Q1 minus the IQR times 1.5. So let's actually do this a little bit on the calculator. So if I get the calculator up, let's just look at the list 1 for a moment here. So if I go to a clear screen, so second mode, make sure my screen is clear here because the one variable stats will appear on this page. So stat right, and then I'm going to click enter. Now here's where I could choose either list 1 or list 2, and you can see that the A button is flashing. You can see how the alpha is already pushed here. So if you wanted to push 2, excuse me, you have to click second 2. That was my mistake. By clicking second 2, you can get to list 2, or second 1, you can get to list 1. Let's go to calculate. Alright, and we're going to scroll down and see the Q3 is 35 and the Q1's 25. That means my IQR is 10. So if I go 35 plus 10 times 1.5, Oh, I should put a plus there, not a time symbol. So 35 plus 10 times 1.5, and I hit enter. I should look to see if there are any chocolates, since I'm in the list 1 here. I should look to see if there are any chocolates that are bigger than 50, and there aren't, so we have no outliers up there. Then we'll go 25, since that was my Q1, and 25 minus 10 times 1.5, and we get an answer of 10. And there was nothing actually smaller than that, so hooray, list 1 doesn't have any outliers. And I could do the same for list 2 if I'd wanted to, but that's just showing you what an outlier check would look like, in case it didn't say somewhere in the problem that you had to assume a normal distribution. Alright, it's time for steps 3, 4, and 5 to finish out the video here. So, steps 3, 4, and 5 allow us to go over to the test menu by clicking stat and clicking over to tests. Look down to step 4, the 2 samples t-test. And you can see that from the previous problem, almost everything was set up right, except that I have to change my test to less than, okay, because I think my chocolates are less sugary than my non-chocolates. And then go to draw, and let's see what I have. So it looks like I've got a one-tailed test shaded on the left-hand side, and I'm going to get my t-value, and I'm going to get my p-value right off the screen. My t-value is negative 1.2203. My p-value is 12.03%. So let's write that down in step 3. Okay, and let's draw the picture. My beautiful t-curve shaded on the left-hand side. Whoops, it was a negative. Don't want to forget the negative there because I got to plant my flag negative 1.22 standard deviations away from the norm, which is just outside of the norm, which means that I'm going to compare my p-value to alpha, and alpha was a very generous 10%, but still the p-value at 12% is bigger than 10%. So we're definitely not rejecting here as well. So let's write our final sentence and get to the end of the video. Since p is greater than alpha, we do not, I like to emphasize that instead of a contraction, we do not have sufficient evidence So excited to get to the end of the video, I'm misspelling everything. To reject the null hypothesis. So that's the fancy statistical way of saying do not reject the null hypothesis. And thank you for including that inequality. You need that for the paper pencil portion. I want you to put that in there so I can see what you found. And with all the other things you've written down, you've definitely done enough for your 2 sample t-test. Thanks for watching.